Key concept 6, target A, B, and C, introduction and congruence. Yeah, YouTube channel is at Mad Videos by Mr. A. Make sure you subscribe so that way you know when new videos come out. Hit the notification button as well. I'll be making videos for Key Concept 6 through Key Concept 14 for Integrated Math 1 Core and Honors. Example 1A. ABCD is congruent to W, X, Y, Z. Name all the pairs of congruent sides and angles. Okay. So remember this symbol right here tells us that those two shapes are congruent. Now that's what we call a congruent statement. We're stating that figure ABCD is congruent to figure W, X, Y, Z. What it means to be congruent is that they have the same shape and the same size. So starting with the angles. Now they're purposely put in a specific order so that we can able to match them up. So first one, A, we're going to give it one arc. It's going to be congruent to the first letter of the second shape, W, so we'll give that one arc as well. So we'll say for the first angle, angle A must be congruent to angle W. All right. Then we'll move on. Second letter should match up with the second letter. So we already used one arc, we'll use two. Angle B must be congruent to angle X. Move on to the next letter, which is the third one, C. 1, 2, 3 arcs because we already used 1 and 2. Should be congruent to the third letter, Y. So 1, 2, 3. And we can say angle C must be congruent to angle Y. Okay. And the last one, fourth letter with fourth letter, we'll use 4 arcs. 1, 2, 3, 4. Must be congruent to Z. 1, 2, 3, 4. So we can say that angle D must be congruent to angle Z. Okay, now those are all the pairs of congruent angles. We need to match up the sides now. Okay. So again, in a specific order, for sides, keep in mind that those are line segments. So they're not a whole line. They don't go on forever. They don't have arrows. They're pieces of a line. So we consider them line segments. So when we write them out, we're going to need 2 letters and we're going to put a little line segment on top. So first 2 letters, we'll give it 1 tick mark. We'll be congruent to the first 2 letters, WX, 1 tick mark. So we'll say that AB, line segment AB, must be congruent to line segment WX. Right. Next, middle 2 letters, BC. We'll use 2 tick marks since we already used 1. It's congruent to the middle 2, XY. Again, 2 tick marks. So we can say that line segment BC must be congruent to line segment XY. Okay. Next, we'll do the last 2, CD. 1, 2, 3. It's congruent to the last 2, YZ. 1, 2, 3. So we'll say that line segment CD is going to be congruent to line segment YZ. Okay, and then the last one we have, it's going to be the first and last letter, AD. So we go 1, 2, 3, 4. It's going to be congruent to the first and last letter, WZ. 1, 2, 3, 4. So we can say that line segment AD must be congruent to line segment WZ. Okay, and now because we have a 4-sided shape, we had a quadrilateral. We labeled the 4 congruent angles and the 4 congruent pairs of sides. Example 2A. Name all the pairs of congruent sides and angles and give a congruent statement. This example is very similar to the one we just did, except we're not given a congruent statement, and the picture already has all the sides and angles marked up for us. So the way we're going to be able to figure this out is by the markings on the picture. I'm going to fix this real quick. This should be angle I. So looking at the figure to the left, we're going to start with angles. We'll notice that angle I has 1 arc. So on the figure to the right, we're looking for which angle also has just 1 arc. That's going to be angle W. So I can go ahead and say right here that angle I must be congruent to angle W because they both have 1 arc, which tells me they're congruent, which tells me they have the same degree measure. All right, moving on. F has 2 arcs. Looking at the figure to the right, we notice that T has 2 arcs, so we can say that angle F will be congruent to angle T. Moving on, we got 3 arcs for angle G. Looking at the figure on the right, U also has 3 arcs, so we can say that angle G must be congruent to angle U. And then finally, for angles, we have H with 4 arcs. Looking at the figure to the right, we have V with also 4 arcs. So So we'll say that angle H must be congruent to angle B. All right, so those are our 4 congruent angles. Now we need to do sides. Again, based on the marking, so looking right up top here, we notice that this line segment, this side has 1 arc. We're going to call that HI. If I wanted to, I could also flip it around and call it IH because it is a line segment, which means it ends in both directions. So it doesn't really matter if I flip it around. Figure to the right, we'll notice that VW has that same 1 tick mark. So we'll say that segment HI is congruent to VW, which again, if I wanted to, I could flip around and call WV. All right, moving on to 2 tick marks now. We'll notice IF has 2. So we'll call it IF. Again, flip it around, call it FI. It's going to be congruent to WT because again, it has 2 tick marks. If I wanted to, I can flip it around, call it TW. Moving on now to 3 tick marks. We have FG, 1, 2, 3. It's going to be congruent to UT, 1, 2, 3. So FG, which can be flipped around and called GF, is going to be congruent to UT, which could also be called TU. And then the last one is going to be HG with 4 tick marks, which could also be flipped around and called GH. It's going to be congruent to VU, because it also has 4 tick marks, which I can also call UV. Now, the last thing we need to do here is give a congruent statement. So name the shapes. The way you name the first shape really doesn't matter. I'm just going to go based off the number of arcs and the angles, just to follow a specific order. So the first arc, or 1 arc, was I, 2 was F, 3 was G, and 4 was H. And we're going to say that that first figure is going to be congruent to the second figure. Now, the way we name the second one needs to be deliberate. We can't just name it any way we want. It has to match up with the congruent angles and sides. So we went with I first. I had 1 arc, so I was congruent to W. Then we went with F, which was congruent to T. Then with G, which was congruent to U. And finally H, which was congruent to V. Okay. So we gave the 4 pairs of congruent angles, the 4 pairs of congruent sides, and we gave a congruent statement, which basically declared or stated that the figure to the left, IFGH, was congruent to the figure on the right, WTUV, which means they are the same shape and the same size. Determine the value of y that maintains the congruence of the figures. So we're told the quadrilateral quad is congruent to quadrilateral lug. Right? And we want to find the value of y. So if you look through the picture, you'll see that the only place that we see y is right here in the line segment QD. Okay. Now, most of the time, if not all the time, when you want to solve for a variable, that means you're going to have to set up an equation in order to solve that variable. So we need to find 2 things that are equal to each other. Based on what we did in the previous examples, QD is the first and last letter of quad, so that tells me that it's going to be congruent to the first and last letter of love, which is going to be LE, which is this side right here. Okay. If 2 line segments are congruent, what I'm telling you is that they are the same length, so they're equal to each other. So we're going to replace QD with the length 5y plus 2. We're going to represent, or not represent, we're going to substitute the length LE for 12. No need to put the measurement in centimeters right now. And now we've created our equation that we can go ahead and solve, and that should give me the value of y. Okay, following the steps to solve an equation, distributive property, there's no need because there's no parentheses. Step 2, combine like terms. On the right, all we have is a 12. On the left, you can't combine 5y or 2 together. Step 3, add or subtract to get all the variables by themselves. You'll notice that all the y's are on the left, so we'll leave them there. We want to get constants to the right, so we're going to get rid of this positive 2 by subtracting it from both sides. On my left, 2 minus 2 will cancel. We can bring down 5y equals, on the right, 12 minus 2 will give me 10. Okay. We know we're done adding or subtracting because all the variables are on the left, constants are on the right. The last step is to multiply or divide. 5 and y next to each other like that means they're being multiplied. So to undo the multiplication by 5, we're going to divide both sides by 5. On my left, 5 divided by 5 is 1, so we say that it cancels out, bring down y. And then on the right, 10 divided by 5 is going to give us 2. Now, keep in mind, the directions were to determine the value of y, which we just did. y is equal to 2 is going to be our final answer. Example 4a, determine the value of x that would maintain the congruence of the triangles. So in this particular problem, we want to find the value of x, okay? You'll notice that the only place we see x is right here in this degree measure. So that tells me that this angle right here measures 2x plus 6 degrees. So we got to figure out x right there. All right, now, in order to figure this out, there's a little bit background information we need to know. These two sides of this triangle are congruent. That's why they both have one tick mark. Which tells me that what we're looking at is a special type of triangle. This is an isosceles triangle. All right, so I'll write this down here just for information. Isosceles triangle. Now, there's a couple things true about an isosceles triangle. The first is that it has two congruent sides. Okay. The next thing is that it has two congruent base angles. Now, the base is what the triangle sits on. So this side down here. Okay. Those two need to be congruent. So if the one on the left is 56 degrees, the one on the right must also be 56 degrees. Now, we're looking at two congruent triangles, or we're trying to make the claim that they're congruent. So if the two base angles on the left are 56, the ones on the right must also be 56 degrees. Okay. Another piece of information we need to know. This angle plus this angle plus this angle should add up to 180. No matter the size of the triangle, the three interior angles should always add up to 180 degrees. The three interior angles of any triangle should always add up to 180 degrees. Now, just like I said in the previous example, we need to solve for a variable. If we need to solve for a variable, that means we need to set up an equation where we can solve for it. Okay? These three angles, when we add them together, should give us 180, and that's where my equation is going to come. So starting with the top angle, 2x plus 6, plus the bottom left, 56, plus the bottom right, 56, should equal 180. Okay? Now we're just going to go ahead and solve that equation. So, doing the distributive property, we have parentheses around 2x plus 6. Notice there's no number that we can easily see to the left of it or in front of it, which means that there's a positive 1 here. If we distribute by a positive 1, if we do 1 times 2x, 1 times 6, you're going to notice that we're going to get the same exact thing, because multiplying by positive 1 doesn't really have an impact on it. So we bring everything down. Okay. Step 2 is to combine like terms. So on the left, I can circle 2x, positive 6, positive 56, and positive 56 will get squares because they're all constants. I'll go ahead and bring down 2x. 6 plus 56 plus 56 is going to give us positive 118, and it's still going to be equal to 180. Step 3 is to add or subtract. All my x's are on the left, we're going to leave them there. We want to get constants to the right, so we're going to subtract 118 from both sides. Okay. On your left, 118 minus 118 will cancel. We'll bring down 2x. On the right, 180 minus 118 will give us 62. And then the last step will be to divide or multiply. We're going to divide both sides by 2. To undo the multiplication by 2. So then it looks like 2 divided by 2 is 1. Bring down x equals 62 divided by 2 is going to give us 31. The directions were to determine the value of x. We did that. So final answer is going to be x is equal to 31. Example 5a. Given that line segment AB and line segment GH are corresponding sides of two congruent figures, find the lengths of the given sides when AB is equal to 10a plus 5 and GH is equal to 7a plus 11. Okay? So we want to ultimately find the lengths of the given sides. Now, we're given AB and GH. Okay, so I'll draw AB here. Here's line segment AB. Here's line segment GH. Okay? We're not told what shape they come from, but we're told that they're corresponding sides of two congruent figures. So we know that there's two shapes, no matter what they are, and that they're the same shape and they're the same size. And we know that AB and GH are corresponding, which means, let's say, for example, if we're looking at a triangle, AB would be the base, and so would GH, which tells me that they must be congruent to each other. So I can say AB is congruent to GH. Okay. Now, we want to find the length of AB and GH. We're told that AB is 10A plus 5, and that GH is 7A plus 11. But that doesn't give me the actual value of the side because there's a variable there. We need to solve for A. If we need to solve for a variable, that means we need to set up an equation where two things are equal to each other. Line segment AB is congruent to line segment GH, which means that they're equal to each other. They have the same length. So wherever I see AB, I'm going to go ahead and replace it with the quantity 10A plus 5. Wherever I see the line segment GH, I'm going to replace it with the quantity 7A plus 11. Okay? And there's the equation that will allow me to solve for A. Now, distributive property is not necessary because there's no parentheses. Combine like terms on the left, 10A plus 5 will not combine. On the right, 7A plus 11 will not combine either. Then we go to step 3, add or subtract. We want our variables on one side. It's usually easier to put them where they are bigger to begin with to avoid negatives. The 10A on the left is bigger, so I'm going to want to get rid of this positive 7A by subtracting it from both sides. So on my left, 10A minus 7A is going to give me 3A. I'm going to bring down the positive 5 because we haven't done anything to it. On the right, 7A minus 7A is 0. Bring down the 11. What I've accomplished in that one step is to get all my variables to the left. Now I want to get all the constants to the right. So I want to undo the positive 5 by subtracting it from both sides. Okay. On my left, 5 minus 5 is 0. Bring down the 3A. On the right, 11 minus 5 will give me 6. Last step is to divide and multiply. We want to undo that multiplication by 3, so we're going to divide both sides by 3. And that tells me that A is going to give me a final value of 2. Okay. Now careful here because a lot of times we'll stop here assuming that we solved the problem already because we know what A is. But we're told to find the lengths of the given sides. So now we need to take this information and we need to plug it back into both of the line segments. So we'll start with AB, which we knew was 10A plus 5. But now wherever I see A, I'm going to go ahead and plug in a 2 in parentheses. All right. We're going to plug it in parentheses because 10 was being multiplied by A. Putting A in parentheses will remind us that we need to do that multiplication. So AB is equal to 10 parentheses 2 plus 5. Now we're no longer solving this side. We're simplifying the expression. So we're going to use order of operations. Please excuse my dear Aunt Sally. So we're going to do the multiplication first. 10 times 2 is going to give me 20. And then add that to 5. The final length for AB is going to be 25. Okay, so this right here represents half my answer. The other half is going to come from us doing the same thing, but now with the line segment GH. So we know GH to be 7A plus 11. Again, wherever I see A, I'm going to go ahead and plug in a 2 in parentheses. Using order of operations to simplify this expression, we're going to do multiplication first. 7 times 2 will give me 14. Add that to 11. We're going to find out that the final length of GH is going to be 25, which will represent the other half of my answer. Okay. Now, just to recap, first thing I needed to do was set the two line segments congruent so that I can solve for A. Once I solve for A, I need to plug it back into the line segment AB and the line segment GH. You'll notice that AB and GH ended up having the same length, and the reason for that was because they were congruent, or we made them congruent so that we can figure out what A value would ensure that they give us the same length. Example 6a. Given that rectangles ABCD is congruent to EFGH, find the measures of angle A and angle E, given that the measure of angle A is equal to x plus 12, and the measure of angle E is equal to 4x. Okay. This is similar to the previous example we just did, except now instead of finding the sides, we're finding the measures of angles. Keep in mind that this M in front of the angle just means measure. So we're trying to find the measure of angle A, we're trying to find the measure of angle E. However, both of those have x's inside of them. So we need to figure out what x is first before we can then plug it in and find the actual measure of those angles. Now, if we need to find x, that means we need to set up an equation. So we need to find two things that are equal to each other. Ideally, it would be A and E because those are the angles given to us. So if you look in the first shape, angle A is the first one. If you look at the second one, E is the first one. Okay. We learned in a previous example that the way they order them, the congruent statement is actually on purpose. So first letter goes with first letter, first angle goes with first angle. So that tells us that angle A must be congruent to angle E. Okay. And if I tell you that two angles are congruent to each other, I'm telling you that they have the same measure, so they're equal to each other. Now, wherever I see angle A, I'm going to replace with the quantity x plus 12. Wherever I see angle E, I'm going to replace with the quantity 4x. Okay. Here's my equation that I'll be able to solve x for. No need for distributive property because there are no parentheses. If we try to combine like terms, on the right, there's only a 4x. On the left, we can't combine x with 12. Step 3 is to add or subtract. I want to get all my variables on one side, preferably where they're bigger in order to avoid negatives. The 4x on the right is bigger, so I want to get rid of this positive 1x on the left. I'm going to subtract to undo it. Okay, remember, it's called using inverse operations, operations that undo each other. On the left, 1x minus 1x will cancel. I can bring down 12. On the right, 4x minus 1x will give me 3x. Okay. I know I'm done adding and subtracting because all my variables are on the right, all my constants are on the left. Now, last step is to multiply and divide. I'm going to undo the multiplication by 3 by dividing by 3. On my left, we have 12 divided by 3, which is just going to give us 4. On the right, 3 divided by 3 is 1. No need for a coefficient 1, so we bring down x. Now, we saw for x, what's left is to plug them back into both angles so that we find their degree measure. So we'll start with angle A, which we were told was the quantity x plus 12. But now we know x to be 4, so wherever we see x, we're going to go ahead and plug it in. This time around, I'm not going to put parentheses in it because x is not being multiplied by anything right now. It's just being added by 12, so there's no need for that reminder. So the measure of angle A equals, plug in the 4, plus 12. Tells us that the measure of angle A is going to be 16 degrees. Okay, degrees because we're talking about angles and that's how they're measured. Now we need to find the other angle, angle E. We were told that the measure of angle E is equal to 4x. Wherever I see x, I'm going to go ahead and plug in a 4. This time it will be in parentheses because there's a 4 in front of it, which tells me that these two need to be multiplied. So the measure of angle E is equal to 4, parentheses 4. Which gives me the final answer. The measure of angle E is going to be 16 degrees as well. Okay. And again, the reason that played out the way it did is because we were told that the angles were congruent, or at least we figured it out. So it makes sense that when I finally do solve them, that they have the same exact degree measure.